Welcome back to Mrs. Law's class. In this lesson, we're going to take a look at powers and exponents. So to start us off, let's take a look at some definitions so that when I talk about powers and exponents, we all use the same terminology. So the first thing here, we have 2 to the power 7, and the 2 is called the base. The 7, which is raised to the right of the 2, is called an exponent. And then the whole entire thing is called a power. So 2 to the 7 means 2 times 2 times 2 times 2 times 2 times 2 times 2. So it means that there are 7 2's multiplied together, and we can think of it as it's written as a repeated multiplication. And then 2 to the power 7, when we actually multiply it all together, we get 128. So we would say that this is written in standard form. So 2 with little 7 raised, so 2 to the power of 7, this is called exponential form. When we write all of these 2's multiplied together, this is called repeated multiplication. And then once we multiply all of these numbers together, we have 128, which is called standard form. So when you see the instruction to evaluate a power, that means to find the answer in standard form. Now please note that the base and the exponent are not interchangeable. So in other words, 2 to the power of 7, for example, cannot equal 7 to the power of 2. So remember that 2 to the power of 7 means 2 times 2, 7 of 2's. And that does not equal 7 squared, or 7 to the power of 2, which means 7 times 7. Now here's the challenge. Can you think of one example where the base and the exponent can be switched and the answers are still equal? So let me give you a little bit of time to think about an example. All right, did you think of one? Well, one of the most common ones, of course, is just 2 squared equals to 2 squared. Of course, any number where the base and the exponent are the same, because can always be interchanged. But a really good one is 2 to the power of 4, which equals 4 to the power of 2. And so we know that 2 to the power of 4 is 2 times 2 times 2 times 2, and that equals to 16. And then 4 squared is 4 times 4, which also equals 16. All right, let's take a look at a couple of powers with positive bases and what they look like. So if you have a 4 squared, or 4 to the power of 2, this means that the exponent is 2. This is called a square number. So recall that means that we have a side length of 4 on each side. And then when we count up all of the squares, we have 16 of them. So 4 squared means 4 times 4, each of the side lengths, and that equals 16. Now when it's 4 to the power of 3, or 4 cubed, or the exponent is 3, this is called a cube number. And a cube number can be represented with a cube, or some people might say it's called a rectangular prism, with all the sides equal. So we can see that the 4 squared is represented on the bottom of the cube, but once we go 4 cubed, we need to go in 3 dimensions, and we need to add 4 more layers. So 4 cubed is considered to be 4 times 4, we can think of that as the base, and then times another 4 to say what the height of the cube is, and that is equal to 64. All right, now let's take a look at powers with negative bases. So here we have 2 examples, negative 4 in brackets squared, and then in the second example we have negative 4 with no brackets squared. So the brackets are really important because they tell us that the base in this first example is negative 4. So when I square negative 4 in this case, we have negative 4 times negative 4. That means that the exponent 2 is being applied to everything inside the brackets, so the negative 4. And that's going to equal 16. So we can see that when there is an even number of negatives, or when the exponent is an even number, then the product is going to be positive. And remember that product means the answer to multiplication. Now, if we have negative 4, but this time it's raised to a power of 3, we're going to have negative 4 times negative 4 times negative 4. And that equals negative 64. So we can see that there's an odd number of negatives this time. Because there's an odd exponent, then we know that the product is going to be negative. Now let's contrast that with this example here where we don't have the brackets. So here we have negative 4 and squared. Since we don't have the brackets, the exponent 2 only applies to the base. And the base here is only 4, not the negative sign. Now that means that the negative sign applies to the entire expression. So what that means is that we have negative, and then we have the 4 times 4. So if I put brackets around what we are only squaring, we're squaring 4 squared, that means we have 4 times 4 in brackets. So then we have negative 16. Now notice that when it's cubed, we have negative, and then we're going to go 4 times 4 times 4, and that still gives us negative 64. What you can think of is that negative sign, it actually means negative 1 times 4 squared. Or if it's negative 4 cubed, you can think of that as negative 1 times 4 cubed. And that's why in these two expressions, the value will always be negative. All right, let's finish off with 3 examples. So here we have negative 7 in brackets, and it's squared. So the base is negative 7. So negative 7 is the base. And then evaluate each power means to find the answer by removing the exponent. So here we have negative 7 times negative 7, which is positive 49. In example 2, the base is only the 7 because there are no brackets actually. So 7 is the base. And that means that we have 7 times 7, and then we still have a negative sign. So this one's going to be negative 49. All right, now the third one here, 3 is the base, and then the 5 is the exponent. So that means we're going to go 3 times 3 times 3 times 3 times 3, 5 3s multiplied together, and that's going to give us 243. And it's helpful to have maybe the first 5 values or bases memorized, maybe up to powers of 3, 4, and maybe even 5. And that's what a power is and how you evaluate them.